Hi, today we're looking at a hot tub that is not heating the water correctly. Filled it up, turned it on for the first time this season, and the water temperature stayed pretty cold, only shifted by a few degrees after turning it on and running with the heater on all night. I think it was just warming up from the ambient temperature rather than the heater. Certainly running all night, it should have brought it up to the full 37 degrees centigrade operating temperature. So I believe on this one the heater element has gone, and the way to discover what is wrong with it is detailed now. So first of all, check when you power it up that the heat available and the heat on lights are operating. At the moment I've got this disconnected, but if the heat available light is not on, that means the water pressure sensor on your hot tub has not detected that water is flowing and therefore is disabling the heater. Could be two reasons for that. You could have air in the motor, so sometimes the air in the motor just clears out by running it for 5 minutes or so, and the bubbles will eventually come out and it will start flowing correctly. Sometimes you might need to open the bleed valves on the motor. So here is the motor and the pump on the second jet. This is a little bleed valve, so you can open these up to let the air out until water starts flowing, and then the full pressure of the water being pumped will start happening. The other thing that can happen, and did happen also on this one a little while back, which I haven't changed yet, is the pressure sensor had broken off. This is actually the water pressure sensor that screws into a pipe that's over at the back there. I'm not sure you can see that. I've temporarily got a bolt on it, which is here. That's where the pressure sensor went, and it's basically in the same pipe that has the water heater on it. And this one actually broken off, and to actually temporarily enable the pressure switch, I put a bolt in the end just to push on the diaphragm to enable that sensor. That needs replacing, of course. Really, it's a safety feature to make sure that heat doesn't come on if the water isn't flowing, and therefore the heater would overheat, possibly burn out. So it's a good idea to have a pressure sensor operating, but back on properly. I'll get around to doing that eventually. So if that has gone, you'll find that heat available light is not on. Once you activate the pressure sensor, heat available light will come on. Heater on should come on, providing you've got the temperature set to a temperature higher than what the current temperature is, and you've got the heater on switch on, either manual or time clock enabled with a time clock on, and a spar on, of course. If it's still not heating, then you need to work out whether it's maybe a fuse or relay connection, wiring, or the heater element. So inside the control box, take the lid off here. This is quite an old-fashioned spar, by the way, quite a few years old. So each of your individual spars may vary, but probably all are based on a similar principle. They'll have the mains wiring coming in, maybe some fuses, some relays, and some connector terminals. These are just a connection block. So on these particular relays has a little indicator, says 0 or 1, and as the relay activates, this little bit of plastic flips across from one side to the other, so you can see which relay is working. If you flip the heater switch on and off, and the heater light will go off and on, you should see one of these relays activating, so you'll know which is the relay for the heater. On this one it turned out to be this particular relay here, and what you want is a multimeter like this one. So turn it on to 600 volts AC setting, so 6 volts with a little wiggly line on it, 600, and be careful you don't touch any of the wiring, don't get yourself an electric shock. And you can see here on this relay there's 2 wires coming out, in black and a red for live and neutral being black, and you can measure the voltage coming out by putting your probes on top of those 2 screw terminals like that, and as the relay activates you should see, in this case, 240 volts because we're in the UK. If you're in the US it's about 110. That means you've got power coming out of the relay, if that is the case. If you haven't, then it's possibly a problem with the relay or the fuse, so trace the wiring back to where it goes to. It could be, well, one of these screw-in fuses. These fuses just unscrew like so, and you can measure the resistance of the fuse using the multimeter. Put it onto the ohm scale, which is this little symbol here, which stands for ohms. Put it on 200, and that should read 0 when you measure the two ends of the fuse, which means a short or a connection between the two ends, which is what you want. If it's reading infinity, which is indicated on the multimeter by just one dash dash dash, then it means the fuse is gone and you need to change the fuse. Keep an eye on whether it goes again. Might be a reason that the fuse is going. So if, like this one, you've got power coming out of the relay, these two wires go over to this connection block here. So these wire connectors release by putting in a small screwdriver into this slot here, pressing it down and then pulling the wire out at the same time. Put your multimeter in the two connections again. Measure if you've got 240 volts AC or 110 volts in the US coming out of there going to the heater element. So this connection is the power to the heater element. This goes off through this conduit here, goes off to, right, buried out the back there somewhere, the heater element, which says on the top heater. You see it's got a safety cutout switch on the side of it as well, which I tried pressing, didn't make a lot of difference. And I also measure with my multimeter on the ohms scale, so maybe a bit on 20k or something. Make sure your meter is reading or working correctly by shorting out the probes. And it should read 0, which it does. If you then measure across the heater element, like so, if you've got infinite resistance like I have, it means the heater element is either blown or the wiring to the element has broken or disconnected somewhere. Suspecting the heater element has blown. So what we need to do is get out the heater unit. So to do that, we need to probably move some of the other units out of the way. So I've jacked up the tub on some pieces of wood, just in case I need to get some nuts or bolts underneath. I've actually removed 4 bolts holding the control unit in place. These switches, they're like pressure pipe switches, which goes to the switches on top of the hot tub, can be just pulled off to enable you to lift the control unit out of the way. So then we can see we have the heater unit over here. It's somewhat old and corroded. So it says on it electric heater. There's the conduit pipe for the electrical connection going in, and we've got a clip holding it down onto the wood, and we've got this nailed nut which connects the water pipes. Quite stiff, too stiff to undo it by hand, so I brought along a couple of things to try and undo it with. It's a big wrench and also a chain, especially an oil filter removing chain, which is useful for wide things. So you hook it round some circle object or whatever you want to undo, hook it onto the end like that, and then as you pull it both tightens and enables you to turn it. So we'll try that as well. So looking from the pipe end down towards the heater, I think that nut should turn anti-clockwise. Oh, and don't forget to drain your hot tub first. What we could also try, and what I'm going to try first, is this wrench, quite large. Grab it around some of the edges of the large nut, pull it around. Actually, that does manage to undo the nut. Once you've started with it, probably do it by hand now. Yeah, we can. I'm guessing some water may come out of it. So to get to the other side of the heater element, it's going to be easier to take this pump out of the way. So undo the 2 connections to the pump, push the isolator valves down around it to minimise the water loss, unscrew the bolts from where it's mounted, and then hopefully with this undone we should be able to move the pump out of the way. Yep, that moves fairly easily. That's that out of the way, and then we can get to this heater element unit a bit better. So it's quite difficult to get the wrench around this particular nut, so this time I'm going to use the chain wrench, and it's hooked on like so. Had to lift the pipe up a little bit to get underneath. And then we'll try and get it to turn this time. There we go. So now we can get that moving. Hopefully do the rest by hand. So quite a useful tool, that chain wrench. Now we can do the rest of it by hand, and with these mounting clips undone, we can then lift the heater unit out of the way. And what we'll do first is we'll open up this box and see what we can see inside, whether perhaps any contacts have corroded or anything like that first. Here we can see inside the pipe where the actual heater element is. So now we've just about managed to unscrew the screws that hold the lid on. Needs a bit of WD-40 anti-seizing agent oil, lubricating oil, and inside it's a little bit corroded, no water in there. Just starting to measure the resistance across the heater element, which you can see the red and the black wire coming into this terminal block. Still infinite resistance across there, but then looking closely, moving this wire, you can see that is actually disconnected, either corroded or burnt out from the actual heater connection. So there the spade terminal has burnt out. Quite a common thing with spade terminals, because what you find is the surface of the spade terminal actually corrodes or oxidizes, which makes it a little bit resistive, and where you've got a resistance, you have power being dissipated, and therefore it gets hot, and that's just what's happened there. It's basically got hot and burnt out. That's quite black, that terminal, so we'll clean that up and then we'll just remeasure the resistance again. We'll take the other one off while we're at it as well. So now, after we've cleaned up the terminals, so you can do that with a bit of sandpaper or something like a sanding disc or something to your electric drill. I just happen to use a drill bit, just running it over the surface like so, just because I had that handy. And now when we measure the resistance, put our meter on the 200 ohm scale and put the probes across the heater element. Now we've got a good electrical connection. Before it was very corroded and it was very difficult to get any reading with the probes. And now we get about 18 ohms, which is showing the heating element is still working. It's, I think, roughly the right resistance. And so what we've got to do is replace these, well, mainly this one spade terminal. I think maybe the other one could do with changing as well. It's getting a little bit old. So next I'm going to actually change the wiring as well as the spade terminal connections. So I've got this quite nice bit of 27 amp cabling. It's only 13 amp that goes to the heater element, so that's more than enough, nice and thick to stop the wire getting hot like it was before. Some new spade terminal connections from my crimping set, so you can get these at like motorist accessory shops, Halfords and so on, or probably from eBay. I'll see if I can find some on eBay or Amazon. There's some links in the video description. And if you haven't got pre-insulated spade connections, then maybe some shrink wrap material to insulate the ends could be a nice little job to finish it off. This set is in various sizes. So we strip the insulation off the end, poke it, twist the end, poke it into our spade terminal, then get the crimping tool. It's colour coded, so for this slightly bigger yellow ones, we use the yellow dot on the crimping tool. And you put it round where the wire part of the cable has gone into the spade connector. Make sure it's all lined up and give it a firm squeeze like so. I like to squeeze the end of it as well so it clamps the plastic as well. Like so, give it a good tug, make sure it's not going to come apart. Good look down the end. Yeah, that seems fine. So then we just strip the insulation off the other end, which this crimping tool also has a wire stripper connection on. So I think that one's about right. And give that a slight squeeze and a twist round and strip off the end, like so. So that's with the new spade terminal connections and wiring. Gave the end a little bit of a squeeze with the crimping tool as well to make sure it's going to stay on there nicely and good connection, because the spade terminals of the heater element were a little bit corroded and therefore got a bit thinner, so it's also a good idea to do that. So now it's just a matter of reassembling, put the lid back on, might put an extra bit of sealant around the lid, stop any water getting in, which maybe is the source of some of the rust and corrosion in there. And then we'll just check the resistance back at the control box, make sure it's still about 20 ohms, and then reassemble, fill it up, check for leaks, and then hopefully it'll be working. Let's see. It's quite nice to do a job like this where it hasn't cost any money, so no new heater element was required, which are probably quite expensive. And there we go, make sure they're connected properly, give them a bit of a tug. If you look down the little hole while you're pressing in with the screwdriver, you can actually see the jaws open up as you push in the screwdriver, so to actually see how those work. And now everything's wired back up. If we measure the resistance again, so there we are at the relay connection output, which goes to the heater element. Resistance across those terminals 18 ohms, of course with everything off. So the heater is now connected, so hopefully now we can power it all back up again and the water will start heating. So make sure the air is bled out of the pump before you turn on the heater. Make sure the water is pumping around properly. So that's how to fix your jacuzzi if the water is not getting hot. Hope that helps somebody with theirs. And there it is, all on with the water starting to heat. Thanks for watching. Bye.